Hi, welcome to our final video for this unit over the Pythagorean Theorem. This one's about the converse of the Pythagorean Theorem. And that vocabulary word converse, it might not be one we're too familiar with. But basically it means that if you look at it the other way, instead of the Pythagorean Theorem as it's given, if we reverse it and said, the Pythagorean Theorem says if you know you have a right triangle, then you can figure out a side length. But the converse basically says if you have some side lengths, we're going to figure out whether it's a right triangle or not. So if you look at this example here of this piece of string, this distance is 8, this distance is 15 centimeters, and then this distance is 17. If we folded those strings up, at these different points here, each different segment, would this 8 swing up and would this 17 swing up to actually form a right triangle? That's kind of what we want to think about. And it's going to be close maybe. It's kind of hard to tell to see what happens. We can kind of do a test today. That if I give you any three numbers, like 9, 12, and 17, if I make up any numbers, you'll be able to know and tell if they do form a right triangle or not. So let's look at just an example of kind of just looking at some triangles on a piece of paper here. So if you look at this one, and I apologize, I can't make it too much bigger. So hopefully you can see this pretty well, unless you're using a smartphone here. But if you look at some different things, I want you to focus on the purple side, the left side, the 7 length, and then the above one, the 12 length, and then 13.89. So each of the three side lengths is what we're looking at. Here we do have a right triangle. This box up here at the top is 90 degrees. So we do have a right triangle, and 7, 12, and 13.89 would form a right triangle. But if you notice, if I just move this red segment and make it a little smaller, there's 11. Okay, now we don't have a right triangle anymore. So there's really only one specific arrangement of this 12 side that makes a right triangle. If I make it 13, it doesn't make it a right triangle anymore. And then it also changes the other side as well. So if you change one side, it kind of has an effect on it. We can kind of make them smaller. We can make one side 5. 5, 12, 13 is a right triangle. But 5, 11, 13, 5, 11, and 12.08 is a right triangle. So if we change this, we're getting a bunch of different right triangles. 3, 5, 7.07. These are all values that would work. 5, 7, and 8.6. 5, 9, and 10.3. So when you change certain things and certain arrangements of things, we'll get different ones that don't create triangles or do create right triangles. So here we have 9, 6.71, and 8.49, and those are all different lengths. There you can see that they're not right triangles. If we made them all, I don't know if I can do this, but if we made them all 9, an equilateral triangle, it's not going to let me quite. We can know that those different numbers definitely aren't going to be a right triangle. So let's go back to just looking at a few examples of this. Remember, the converse is basically telling us if it forms a right triangle or not. And here are about, 4, 5, 6, 7, 8, 9 examples of Pythagorean triples. These numbers all form sides of right triangles. And if you notice, these numbers are in order from smallest to biggest. They don't have to be, but that's typically how you'll see them. 3, 4, 5, 8, 15, 17. All these numbers, no two are the same. They're all different amounts, and they kind of get progressively bigger as they go on. Kind of a cool thing is if you take one of them, like 5, 12, 13, and double all of them, you get the one right below. 10, 24, 26. And that works for this one over here for all of them, basically. You can generate some more by just doubling the one you have. 10, 24, 26. If you double that, we get 20, 48, and 52. That would be sides of a right triangle also. If you Google Pythagorean triples, you can definitely find some other examples of Pythagorean triples, or just multiply some of the ones we already know by a factor. So we'll look at a few examples here of whether or not they would form a right triangle or not. Now, the thing here is don't let the drawing deceive you. So I know that this one looks like a right triangle. I know that this one looks like a right triangle. But if we physically try to construct it, if we had a piece of string that was 8 and a piece of string that's 15 and a piece of string that's 17, would they actually be put together to form a right angle or not? So what we're going to do is, first of all, put the numbers in order and see if they actually form a right triangle or not. So we're going to do a squared plus b squared equals c squared. And we're going to need to put them in order like I just said. So from 8, 15, and 17, we have 8, 15, and 17 in that order. 8 and 15 have to be the legs, and 17, the longest side, has to always be the hypotenuse when you're testing it out this way. So we're actually going to plug in numbers and see what happens here, and we're not trying to find a missing side because we know all the sides. So 8 and 5, that should be 15, sorry. 8 and 15 are going to go for A and B, and then 17, the longest side, is going to be C squared. And if you want to, you can put, there's a few different ways you can do it. You can put a little box in here if you want to, just to see we don't know that it's equal right now. Or you can put a little question mark above it. But if we actually multiply all this out here, 8 squared, 64. 15 squared is 225. And we want to see if that's equal to 17 squared. 17 squared is 289. And make sure you're doing these along with me, and if you need to push pause and go back and watch it again, that helps. If you have questions in class, make sure you ask me. 64 plus 225 gives us 289. And we kind of find out that actually this is the case. 289 does equal 289. So this does form a right triangle since it's true. So this actually forms a right triangle. You'll find that if they're equal, then they form a right triangle. If a squared plus b squared does equal c squared, it makes a right triangle. So now we'll try it again for number 4 here. Again, we'll put the sides in order: 12, then 18, then 22. So we'll put them into a squared plus b squared equals c squared. The two shortest ones go in for a and b. So 12 squared plus 18 squared. And we want to see, and that's kind of a habit of me just going there, but we'll put a little box there or a question mark to see if it's equal to 22 squared. So 12 squared is 144. 18 squared is 324. And we'll see if that's equal to 22 squared. Bigger numbers here. 22 squared is 484. So when we add 144 and 324, add them up, we get 468 and 484. So we actually find that they aren't equal to each other. So since they're not equal, we can put a little not equal to symbol in there, just an equal sign with a slash through it. We find that it does not form a right triangle. And let's go back actually to that drawing real quick. We have 18, 12, and 22. So if I go back and let's see if I can create one like that. 18, 12, and 22. I don't know if this will work out. We'll have to see here. It's going to be pretty big. Let's see if I can get it on here. It's going to be too big. Here's 12. 12-ish. 18. It's going to be pretty big there. Yeah, it won't let me go off the screen. Wow, such a great idea, but it didn't work out. Sorry, there's 16. And we're not going to get 22 on here anyway. Sorry about that. Let's try it for maybe a different one if we can. Let's see. The other one we did was still pretty big. Let's try for 8, 15, and 8, 15, and 17. Let's see if that'll work. We got 17 on the purple or the red side. About 17. And then 15 on the blue side. Ish. And 15, close enough. Oh well, that's not working out. Sorry, I don't want to waste your time here. Let's go finish up a few of these up here down here. Go ahead and try number 5 on your own there and set up the Pythagorean Theorem, and we'll see if it works out. Remember, put them in order first. Alright, so we got 10, 20, and 24. So when we put these in order, we'll do 10 squared plus 20 squared. And we'll see if that's equal to 24 squared. So 10 squared is 100. 20 squared is 400. I want to see if that's equal to 24 squared. 24 squared is 576. And we can kind of see that 500 is not equal to 576. So it's does not form a right triangle. Not a right triangle. And that's kind of what we're trying to figure out. Does it form a right triangle or not? And the last one here, we have one about kind of a word problem here. We're going to figure out what's going on with it. This one says a window frame that seems rectangular. So, well, we think it's a rectangle right now. Has a height of 408 and a length of 306. I didn't draw that very well. Let's try that again. So we have a height of 408, so it's taller and not as quite as wide. So we have 408 and 306. And one diagonal's length is 525. So just one of the diagonals here. Again, in a rectangle, both of them are the same. So one diagonal is 525. And they said, is the window frame really rectangular? Well, what we have to do is, if this is a right triangle, if that bottom angle there on the left side is a right angle, then it's going to be a rectangle. So if we figure out if this is a right triangle, it will be a rectangle. So we have to figure out, once again, if this works out. So we have 408 squared plus 306 squared. We have to see if that's equal to 525 squared. Now we're not just adding up 408 and 306 and seeing if that's 525. What we have to do is actually square those, and they're going to get pretty big. So 408 squared. Oh boy. 166,464 plus 306 squared is 93636. And 525 squared is 275,625. So we got to add up, just like before, 166,464 plus 93636, and that gave me 260100. And we can see that that's not equal to this 27,625 number. So it's not a right triangle. So the window is not rectangular. So anytime I give you three numbers, you'll be able to tell me whether or not they form a right triangle or not. Always give them, or put them in order. I'll try to give them to you in order most of the time, but if I say something like, 26, 10, and 4, do those form a right triangle? Well, you would have to square 10 and 4 together, or 10 squared is 100, 4 squared is 16, and add them together, and see if that's equal to the other longest side squared. Thanks for listening, guys, and thanks for your participation in the video lessons. We'll see you tomorrow in class.